We started this module by talking about programming as a way of implementing our software. Um, we discussed it in terms of languages and language design for programming languages. Um, well, you could ask, well, what is better than having to write lines of code using a compiler? And the answer is not having to write lines of code using a compiler, using a programming language. And the way we avoid having to write lines of code is to reuse code. So software reuse is getting a lot of play and has been for years, as we can obviously see the benefits of software reuse, but there are also a lot of impediments to software reuse and why you don't see a lot of people doing it, even though we know it's good for us. We'll talk about both the benefits and the impediments. We'll talk about what kinds of artifacts are reusable, forms of reuse, and one of the forms of reuse is portable software. So just a couple of minutes talking about portability. The benefits to software reuse are obvious. Everybody knows these. Actually, to the executives, if executives, CIO, people like that, what do they see or what do they think about when you say reuse? They think about saving money, right? They say, oh man, if I don't have to pay my people to write lines of code, think of how much we can save. Well, that is the main obvious benefit of software reuse. And this is the one that sort of gets the attention of everybody. But in fact, I don't think cost savings is the most biggest benefit. Let me say it that way. It's not the biggest benefit of software reuse. I think the biggest benefit of software reuse is quality, reliability. And there are a number of reasons why the quality or reliability of the software is better if you build it out of reusable components than if you handcraft the software line by line using programming language. One is that the people who, if you know you're building a reusable component, and you know other people are going to be reusing that, you will probably take more care in building it because you know that you're building it not just for yourself, but for other people. Other people are going to be looking at it, so you'll probably do a better job of designing it. You'll do a better job of documenting that software, so that and probably testing that software, so that when other people get to use it, you don't want them to find defects in it, right? You don't want defects to be lurking in that software. So you'll probably do a better job of building the software. It costs a little bit more to do that, but you get the payback of multiple use, of multiple people sharing, sort of like sharing the cost of building software in the first place. The other part of reliability through multiple use, we'll see later on that the reliability, the mean time to failure metric for software reliability is measured based on how long the software runs without breaking. And the way you normally determine the mean time to failure is through part of your testing process. You measure how many times you can test the software, or how many test cases you can run before the software breaks. And the longer you can go, the more test cases you can run before the software breaks, the more reliable it is. Well, one way to test a lot, run a lot of test cases is just to run, have a lot of time to run, 1,000 test cases. Well, you run one after the other, it takes a couple of weeks maybe. But if you had like 100 copies of the software and ran 10 test cases in each of those 100 copies, you would end up with 1,000 test cases. And you could probably run them all in a couple of days. So you can test, if you had multiple copies of the software, you can test them in parallel. Now, that's due to the nature of software. You cannot test hardware in the same way, because hardware fails for different reasons. Hardware fails because it wears out, and so the reliability of hardware is, in order to do a set of test cases to test the reliability of hardware, you're going to have to actually run the hardware for however long it takes before it breaks. And you can't take 100 copies of the hardware and run each one of them, a 1/100th of the amount of time. You won't you'll get the same results. But in software you can, because each copy of the software is identical to each other copy, and you can run the different test cases on each of the multiple copies and achieve the same effect as running all the test cases on one copy. So that's what we can do. We can make multiple copies of the software and run the test cases in parallel. Well, that's testing for reliability and measuring reliability while you're testing. Well, think of it this way. If I have a software component and I send that out and 50 people or 1,000 people or whatever have reused that software component, they are all using it simultaneously. And if there are any defects found, you'll see those. But if it works properly in all those 1,000 reuses, then you can pretty much say this is pretty reliable software, because not only just one copy is running without any defects, but if there's however many you have in parallel reuse that are running defect-free, then you realize that you have much higher quality, higher reliability software. So you can say for a component, this component has been reused, say 1,000 times, and we haven't found any defects in it in all those 1,000 reuses. That's a fairly high reliability measurement versus, I just wrote this code here and I tested it and I ran a couple of test cases and it didn't fail. That doesn't have as high a reliability measure as, say, 1,000 copies of a component being run without any defects found. Okay, so through the multiple use idea of reusable components, that pumps up the reliability number. Certainly, it's less expensive, and that's the feature that a lot of people like about software. This one, capture of expert knowledge. Who should be writing the software for some critical part of your system? Well, obviously the person that knows the most about that kind of feature. Maybe knows the algorithms, maybe knows the environment, whatever it is. You don't want average programmers to be writing essential pieces of your software. You want the best people you can find. Well, who's going to be writing the reusable components to do these critical pieces? Probably the experts, the world experts. And what you're doing by reusing a component written by these experts is you are essentially hiring these experts to come into your outfit and write this software for you. So you're getting the software written by the key people in the world. For example, before we had user interface toolkits, we had to write the user interface, the windows and the buttons and the menus and everything. Had to write that from scratch using basically character-oriented graphics. And everybody would write their own little user interface widgets. And we had no standardization for one thing, but also the reliability was all over the place. The idea of having reusable graphical user interface widgets, such as the Java Swing toolkit, things like that. Who are the people that wrote the Swing components? The code for those components. They're the world's experts in building user interfaces. And so basically when you're using Swing to build your user interface, you are reusing the efforts of the world's experts in building user interfaces. Same thing if you use the Microsoft tools for building user interfaces, or the Apple tools for building user interfaces. Same thing, you are capturing basically the expert work of world-famous, world-renowned experts on your little application. Now, also by reusing, for example, you're reusing Swing, the Swing toolkit, you are building a user interface that sort of conforms to some standards. So you've got standard user interfaces. If I'm reusing say the interface to a database system, I'm not writing my own database access. I'm using the database features of the database system, basically what it allows for is everybody that uses that database to use it in a standard way. So you get sort of standardization across many applications. Same thing with I/O and everything, right? So if you're using standard tools, standard toolkits, standard libraries, then you are conforming to a standard which allows other people to understand what you've done and allows the maintainers to go in and modify things more easily. There's less schedule risk because the amount of time that it takes to reuse a component is way less than the amount of time that it takes to design the component, handcraft the line by line code the component, test the component, integrate the component. So you get less schedule risk. Your time to market is less. Now, where should we be reusing and where should we be handcrafting our code? Well, there's probably one of these 80-20 rules or 90-10 rules that says something like 80% of the code that we write is sort of ordinary, run-of-the-mill kind of code, and anybody could write it, and so may as well just reuse some components. And then the 20% of the code of my application is very critical, and I want my experts, my people, my employees, to write that 20%. So now, if we didn't have reuse, all my software developers would have to spend their time writing all 100% of the code. The 80% of their time would be spent writing this mundane stuff that anybody could write, and then they leave a much smaller amount of their time available to write the critical parts. If we could reuse components for the 80% of our software, then that would free our developers up to spend 100% of their time on that 20% of the software components that is the critical part, for which there may not be any reusable components. That's the stuff that they are expert on, right? So we're allowing us to sort of devote our experts to what they do best, the expert part of the system. The 80% of the system that is sort of ordinary that anybody can do, let's just implement that using reusable components. So those are some of the benefits of reuse. So you might ask, well, why aren't we all doing it then? Well, here are some of the sort of common excuses for not doing reuse. One is people, if they had to build the reusable components, they just do not know how to do it. They don't, so I take an existing component. Usually these reusable components come from existing work, right? So I've written some software, I've written a class, say, or some subsystem, and I said to myself, somebody else might be able to reuse that, but there are things that I put in there that are specific to my application that in order to make it reusable, I have to pull those things out. Sometimes we just don't know how to make it more general or less particular. The other thing is I left some things out of my system, my subsystem, my package, my class, whatever it is, because I didn't need them on my application. And we may need to add some of those things in order to make the component more generally reusable. And once again, we may not know, right, as developers, what to add to our components to make them more general. We may not know, but there may be somebody, some reuse expert on our staff that understands that. So the way around this first impediment is you need experts on reuse to mentor people as consultants to come into the group and say, all right, tell me about your reusable components or things that you might think would be reusable, and let us work on those to add things to make them more general, to delete things to make them less particular. Now, there's also, as we talked about earlier, there's an extra cost to make components reusable. I had to take extra care in building it. I had to test it longer. I have to document it better. We have to add more, add stuff to make it more general. Have to delete stuff to make it less particular. There are things that we have to do in creating a component that adds to the cost, above and beyond just writing the component and putting it in our application. So there's also the question about if I have to build my system, plus then I have to take some of my components and make them reusable, that's extra cost. The question is who pays for that? And an enlightened organization will sort of eat that cost. They will realize it's sort of an investment in the future. to do the things necessary to identify these components and put them into a library and make them available to other people. But that's an enlightened position. Not everybody buys into that yet. I got the old NIH, not invented here. It is probably true that, given, if I look out there, look at the components that are available for doing some particular subsystem, I might not find anything that's an exact match for what I need. And if I handcrafted the component myself, it would be perfect. I could always do better than, the other people out there. Well, that's probably true. We might be able to do a better job on some small subsystem than any other component out there would be able to do. You have to ask yourself, though, how good does it need to be? Right? As I said, we've got this 80-20 rule. Let's devote our total attention to the 20% of the software where we can make a difference. For that 80% of the software where it doesn't really matter, let's reuse some components. Lack of search and retrieval mechanism, well, that's no longer an excuse. We have tons of search and retrieval mechanisms using the internet for finding all sorts of things. Google, for a good example of that, right? So we can't use that as an excuse anymore. There might still be some legal issues. This is a killer. You got the intellectual property rights. Let me take that one first. I spend some time writing this component. I put it out in the library, and somebody else just in my own company reuses that. They use that component, and they end up with a piece of software that is that sells a lot and brings in a lot of revenue to the company. And this person gets a big raise, a big promotion. And am I entitled to any of that? Because they reused my work as part of their application. So that you might want to say, well, gee, give me some of that, right? So intellectual property means, well, when you reuse this component, you are using the work of my intellect, it's my intellectual property, and I'm entitled to some, like a royalty, right? So some places they've set up these little royalty payments. So every time somebody reuses the component, the implementer of that component, the original implementer, receives a little royalty payment. You might be able to solve those kinds of things, but usually what you'll do is you just, for the good of the company, you'll put these components in and make them available. The liability issue is the killer. This is the one that will actually stifle any reuse effort. And what we solve this problem, you can see this every time you install software, you see this big license agreement, right? And that's to get around the liability issue. So certainly anytime you reuse software, you will have to subscribe to this. But if you didn't, think about this. I reuse a piece of software, or let me, my software, the component that I wrote, is being reused in somebody else's application. I have no control over who reuses it. Now, that's the first thing, right? So they reuse it in their application, unbeknownst to me. They sell their application, and it causes some big failure. People lose money, maybe somebody gets harmed, maybe it's a medical system that actually injures somebody, or worse yet, kills somebody. The lawyers all swoop down on the guys that wrote the software, and they find out that they reused a component that was written by me. The lawyers are going to certainly come after me as well, right? And that is going to stifle any reuse effort. So I'm going to say, nope, no more. I'm not going to reuse. I'm not going to put my stuff out there, because if I'm going to get sued, I certainly don't want to lay myself open to any of that. So I just won't reuse. Well, that is the big thing that will stifle the reuse. So that's why we see all of this fine print. Anytime you reuse anything, anytime you install anything, you have to basically say, the person that wrote the original software is not liable for anything that might go wrong here. And that seems to have worked. I mean, the lawyers have seemed to have figured out how to write those agreements, those license agreements, in such a way that the developer of the software is protected. This last one, trust and certification of the components, this is a big one. I have a retrieval mechanism, so I can go out there. So now I've got a set of requirements for my software component. I know somebody has written that component. I know it's out there somewhere. So I go out to my retrieval mechanism, and I say, and I put in the requirements, and I do a search, and I find 5 components that all might work. How do I know which one is the best one? Well, the author of the component says, I'm the best one. You really can't rely on the developer of the component to tell you anything about the quality of the component. You can't even say that, rely on the fact that they say we've tested it 10 hours or we've tested it 1,000 test cases or whatever. You can't rely on that because you don't know the quality of the testing. So how do you know whether the component is any good? You can't rely on the person that wrote the component to tell you whether it's any good. So who could tell you? Well, the other people that reused it could tell you. So every time somebody reuses a component, if they would put back some feedback back in the library, then you could just peruse the feedback from people that have reused that component. So you get like a rating from 1 to 5 or something like that. I mean, you see this with, if you go to Amazon, if I want to buy a book or a CD or something, I go to Amazon and I can see reviews of other people that have bought that same book and decide whether I want to buy that book or not based on the reviews from these other people. And should do the same thing with components then. I look at the library of components, and in addition to the sort of the specification of the component that the author puts up there, I see the reviews from other people that have reused that component. And I can tell, based on their feedback, whether it's any good or not. The other way to get the feedback from some third party would be to have some independent third party do testing, independent testing. This is sort of the Consumer Reports model. Right? So if I want to buy a new car, a new washing machine or something like that, I'll look that up on the Consumer Reports magazine. And what they do is they have labs that they go out and they buy these products and they test them out in their labs, and then they rank them and rate them, compare them, and show the comparative ratings of all these things in their magazine. So if we could do the same thing with software components, have a third-party, independent, like a Consumer Reports function for reusable components, then based on the evaluations of their independent testing, we could determine which components would be best.